Then we have to discuss side distance. So what do you mean by side distance? Side distance is, you see, now the distance that is visible for a driver in front of him, like this. Now if this vegetation came here, what will happen to this line of sight? It will be reduced. So if the vegetation is here, the line of sight will be like this. If the vegetation is here, the line of sight will be very much restricted. Okay. Side distance is unobstructed distance of roadway ahead visible to the driver. There are multiple types of side distances that include stopping side distance, overtaking side distance, and continuation side distance. So we are going to discuss these three. Right now, remember this is Oxford's terminology. Okay, Oxford means Australian road standards, right? Now, sometimes in American standards, AASHTO, they call this overtaking side distance passing side distance. Okay, so if you see somewhere in a textbook, passing side distance, that's the same thing, right? And side distances are provided for the vehicles to cater for following situations. What are they? Why do we provide side distances? To stop when approaching an obstacle. Just think that you are driving on the road very nicely, listening to some Beatles song or something, and suddenly a little fellow jumps into the road following his ball. So you should be able to stop at once. Okay, and then the other one, or sometimes you are traveling on the road and there is a person who has fallen on the road. So you should be able to apply brake. And the other one is when it requires to take a decision regarding overtaking, whether we should overtake or not. Now, if you have driving licenses, of course, you guys always do this when you drive. Sometimes when so you take a decision whether I should overtake or not. Okay, we assist you. The RDA assists you. How? Giving you dash line or the continuous line or double line. Okay, but sometimes you think, okay, we don't want their assistance. I'll take my own decision. Then what happens? And then there is a cop waiting and he will give you a ticket, right? So when it requires making an assessment of the course of action to be taken at an intersection, so the side distance at the intersection should be uh, really maintained. Otherwise, what happens? That will be accident prone. Okay, so there is some little bit of theory stuff. Okay, constants used. In designing the side distance, following values are used as standard RDA values. Okay, so please understand these values change depending on the country. Okay, so you know PIEV value. Okay, or the total reaction time TR, which is defined as the time between the instant the hazard comes into view and the instant the vehicle begins to slow down after the brakes have been applied, is taken as 2.5 seconds. So what do you mean by this? Now you know, uh, when you see an obstacle, when you see an obstacle, there is a process going on your head. You see it, that means, okay, so you see the obstacle, that means that visual signal has reached your eye and the eye has to give that news to your brain. There is an obstacle. Okay, and then the brain has to process that information and it has to give the order to your leg, press the brake, and you have to press the brake. After pressing the brake, the vehicle takes some time to stop. So, from the instant that you get that visual signal and up to the point that you press the brake, that is what you call total reaction time. So, we through the research, people have understood For that activity, it takes 2.5 seconds. Processing, that means reaching that visual news or visual information to your eye and up to the pressing of the brake. So it takes 2.5 for an average healthy man who is not under liquor, right? So that means he has not taken drinks. If he has taken drinks, this time is going to be high. Okay. And for a person whose eyesight is not very proper, then this time is going to be high. And people with the aged people with other disabilities, so this one is going to be very this time is going to be high. This is for an average person who is average healthy person who is not under the influence of liquor, right? Then these are some of the constants. Just you can keep this. We are not going to ask you these things in the exam. So this is driver high height. The passenger car is 1.05 and commercial vehicle is 1.8. Now you know this reaction time in the last slide that I discussed. Now in Sri Lanka we say it is 2.5, and as I remember Indian Road Congress it is 3 seconds. Okay, so that means Indians are sorry, Sri Lankans are smart. Okay, because they can process everything in 2.5 seconds, right? Then approach object cutoff height. Okay, object cutoff height is, so what kind of a height that you are going to see, right? So approaching vehicle is 1.15, stationary object is zero point 0.2, and the vehicle tail height stop light is zero point 0.6, height of headlight is 0.75, upward divergence angle 1 degree, and vertical clearance is 5.2. So these are some constants used. So if you are really interested about highway engineering, of course, when it comes to, I think I started lecturing you with your first batch. Some of them have joined with me in Facebook also. Very nice people, right? So that was, as I remember, it was maybe year 2001, I think, right? So they were so much interested about highway engineering. Why? Why? Can you tell me the reason? Because there were so many job opportunities, right? Now with this economic crisis and everything, uh, the things have changed. But please understand, of course, because we can't do anything about the economic crisis, that is beyond our control. But once this the crisis is over, again we will have lot of job opportunities in the highway sector. You know why? Because you can't design a road for the eternity. Okay, usually it is designed for 10 years or 15 years or something. So just think that we'll have, say, 5 years to come over this economic crisis. So most of the roads will need to be rehabilitated, and the traffic patterns will be changed, and the road sector will have a new boom. So it is better at least you have some understanding of the highway engineering in the university itself. Then once you go into the industry you can quickly catch up. Okay, so the here this is the stopping side distance. Now you can see this is in feet and inches. Why? Because this is from America, right? So these are some this is say 100 feet. This is the object on the road surface, so you should be able to see that like that. Okay, then we'll discuss about stopping side distance. I told you there are three side distances. One thing is stopping side distance, then the other one is overtaking side distance, the third one is the continuation side distance. Okay, the stopping side distance is the minimum distance required for a vehicle traveling at a particular design speed to come to a complete stop after an obstacle on the road becomes visible. Okay, after an obstacle on the road becomes visible. So just think that this is say this one is stationary. Okay, maybe it's broken or something. So here the stopping side distance is before 2 seconds. Now remember, in our case it's 2.5 seconds, right? This may be from America. So American people may be smarter. I don't know, right? Stopping side distance is normally sufficient to allow an alert and prudent driver to come to a hurried stop under normal circumstances. Remember, he should be an alert and prudent driver. So if you are thinking about, say, you are driving, now just think when you go to the industry, your boss called it, right? So now you are thinking about this thing. Now tomorrow I'll tell the culprit this thing and that thing. So are you a prudent or an alert driver? No. Or maybe you had a dispute with your wife or husband and then you are driving, thinking about them. See how much I loved him or her. Now she or he is telling me like this, so you are thinking like that. So are you a prudent or an alert driver? No. Right? So that means when you are on the road, you should be alert and prudent. Why? Because we have designed the stopping side distance for an alert and a prudent driver. Okay. So then, stopping side distance measured from the driver's eye to an object 6 inches above the roadway surface. Stopping side distance is the summation of two distances. The distance traveled during the total reaction time, that is that within 2.5 seconds. The distance traveled during braking time, because according to the car technology, they cannot stop instantly. It will take some time. So we have derived an equation. Stopping side distance must at a minimum be obtained on all vertical and horizontal alignment. Why? If the stopping side distance is not provided, it will be an accident prone road, right? Then the stopping side distance can be calculated from following equation. SSD TRV divided by 3.6 v squared over 254 mu. So what is this? TR is the total reaction time. Please note down in your notes, right? TR is total reaction time. It is 2.5 seconds. Remember, if you get this question in the exam paper, they will not give you what is TR. You should know that, right? It's 2.5 seconds. And then this is the design speed in kmph. And this is the lateral friction factor. Please note down, right? Lateral friction factor. There are two friction factors. Now when it comes to the super elevation, we discuss about what? Side friction factor. Side friction factor is, that means across the road. Please note down, right? Side friction factor is across the road. Lateral friction factor is along the road. Did I say across the curve? No, across the road, right? Across the road. And this is along the road. Okay, so this V should be in kmph. That is why you have these constants. Finally, the SSD will come in meters. Anyway, that we have calculated these things and we have tabulated in our manual. Okay, so if your design speed is say 70, your stopping side distance is 150. If your design speed is 50, your stopping side distance is 65. And effect of grade, if there is a grade along the road. Okay, grade along the road, that means it is not flat. The above stopping side distance is subject to change with the effect of grade on braking distance. Its influence can be shown in the following equation. So there is another 0.01 g. So if they say the grade of the road is 3%, you just put here 3. Don't put percent also. That is why there is 0.01. Okay. And others all are same. Right. Then we are going to discuss overtaking side distance or passing side distance. Okay. The necessity of the overtaking emerges owing to the fact that all the vehicles do not travel in uniform speed. So now don't think that overtaking is a crime. Now in this country, people have a kind of supposition that, or an say an opinion that overtaking is a crime. Okay, it's not a crime. It's a necessity. That is why the road agencies they give wherever possible. They give you know the wherever possible they give the chance for you to overtake, right? So there's a fast moving vehicle, there's slow moving vehicle, and then there comes the overtaking side distance, so he should be able to go this way before this vehicle reaches him. Attention should be focused to design the road such that the vehicles traveling at the design speed has the chance to overtake slower moving vehicles. Okay. To accomplish the overtaking maneuver successfully, son means without, right? That's a French word. So in some of the English documents, they note down this son. Okay, that is, don't call it sans, right? It's son. That is without danger. A driver should be provided with the adequate and sufficient side distance. Okay. They don't undivided road. What do we mean by undivided road? That means you don't have a center median. Overtaking involves the occupation of the road space normally used by opposing traffic. Okay. The overtaking side distance is defined as the distance which should be available to enable the driver to overtake another vehicle safely and comfortably without interfering with the speed of an oncoming vehicle traveling at the design speed should it come into the view after the overtaking maneuver is started. Okay. So despite the fact that the actual safe side distance depends on many variables, the following simplifying assumptions are made. So please understand these assumptions. Maybe there can be an exam question. What are these assumptions? Okay. These are the assumptions that we use to derive the overtaking side distances. Understood? These are the assumptions we use to derive the overtaking distances, side distances. The overtaken vehicle travels uniformly at one step lower than the design speed. What do you mean by that? So, just think that your uh, road design speed is 70 kmph. Now, the overtaken vehicle, that is the fellow in front of me. Just think that I am the overtaking vehicle. I am trying to overtake. So I am at the back. So in front of me, the fellow, just think road design speed is 70. So I can go up to maximum 70. Don't think that I am going to travel into 100 and 140 something like that. We don't consider such scenarios. Okay. Now in fellow in front of me, he is traveling uniformly at one step lower than the design speed. That means one step is 10 kmph. Okay, if the design speed is 70, one step below is 60. So in fellow in front of me is traveling at 60 kmph and I am traveling at 70 kmph. Okay. The overtaking vehicle travels the overtaken vehicle as it enters the overtaking section. Now just think that I have seen, right, now I can overtake. Now I am trailing behind that the fellow in front of me. So if I am trailing behind, what should be my design speed? It is again 60, right? Because I have trailed behind. Now I can't go at 70. What will happen if I trail behind 70? I'll go and knock the fellow down. So I am, as I enter the overtaken section, I am at 60. Then, overtaking maneuver is accomplished by accelerating in the early part of the maneuver up to reaching design speed. So, what I do is, I accelerate up to 70 and then complete in the maneuver at the same speed. So, they don't assume I reach quickly into 100 kmph and then I overtake the person. No. Or we don't assume, we just think that maybe you can accelerate into 70 and then you can overtake him and in parallel we go 60-60, like some people do. The fellow in the LHS is also at 60. I am also going at 60. Oh, no, we do not consider this scenario. So this is an ideal situation. Okay, now I came behind the fellow in 60 kmph and then I accelerated into 70 and then I completed the whole process. That means coming back to my proper lane with the 70 kmph. Okay. And with these assumptions, these are the side distance values that should be available. If our design speed of the road is 70, we have to provide at least 430 meters side distance. If our design speed is 50, we have to provide minimum 280 stopping side distance. Then the third one, continuation side distance. So the continuation side distance means, okay, continuation side distance means now he, the overtaking vehicle, that is me, right? Not the fellow in front of me. Overtaking vehicle is already in the other lane. Okay, already in the other lane. Just think now here, please understand. Now this is drawn as they are driving in the R side of the road, right? Now this fellow is here. Okay, anyway he has come here. After that, he has to take a decision whether I should complete this task here like this or abort. That means, okay, I'll again go back to behind this person. For that, there should be enough side distance. Now, obviously, this side distance is below than the overtaking side distance, because in the overtaking side distance you have to provide enough distance for this person to take this decision also. But now he has already taken this decision anyway. By hook or crook, he has taken this decision. Now there should be enough side distance to for this overtaken vehicle to decide whether I should complete this task or abort. Okay, understood. The difference between the continuation side distance and the overtaking side distance is what? Is the fact that continuation side distance assumes that the overtaking vehicle is already on the other lane when the decision is to be made whether to complete or abort the overtaking action. Okay, the continuation side distance is generally shorter than the overtaking side distance. It is standard RDA practice to calculate the continuation side distance to be twice as large as the stopping side distance. So you calculate the stopping side distance and then you double it, so you get the continuation side distance. Okay. Then if the continuation side distance can be provided, it would automatically fulfill the stopping side distance requirement for speeds greater than the specified design speed. So that is obvious, right? Because if you are going to give double the stopping side distance for the continuation side distance, so then the stopping side distance requirement is automatically fulfilled. Okay, then please understand this is very important. As far as the budget allows, the designer should always explore for means to accommodate at least the continuation side distance throughout the road stretch. Okay, so the best thing is try to give as much as possible this continuation side distance throughout the road stretch so your road is very proper. So these are the design values. Now you see, if your design speed is 70, your continuation side distance is 230. If your design speed is 50, your continuation side distance is 130. Right? Right. Right. So, any questions so far? Yes. Today I am happy that now there are more students here. Yeah. Any questions? Because I am going to start supervision and I'm going to start supervision and I will stop at 10 o'clock for some 10 minutes break. If you have any questions, please can you raise your hand in the sense you can you can unmute and ask me. Yes. No questions. So please raise your voice if you have any questions. No. Right. Then we'll go for supervision, right?